Hello, everyone. I'm Michael from Math Together Canada, and I will present the way I solved the final question of the COMC from this year. So the question states that Veronica has 25 students. These students can choose to point to exactly one other student, and the number of groups after she removes n students of her choice is the number of points that Veronica will get. Sorry. So, for example, if this is all the remaining students, then she will get 2 points because there are two groups here, right? So this is a group, this is a group, so that's 2 points. So now let's answer the question. So for part A, she can only remove one person, right? So the students can point to each other in the giant loop like this. And no matter who Veronica chooses to remove, she can only choose to remove one person, right? So let's assume she chooses this one. Everyone else is still in a giant group. And that means that Veronica can only get 1 point. And it's not like the students can make Veronica only get 0 points. That's impossible because Veronica guarantees 1 point like by default. So the answer is 1. And I think this was pretty easy, like 2 marks for any people who wrote the contest and got this far. Now for part B, the answer is 100, and part C, the answer is 675. And it might not be so clear why the answer is not like 1,000. So I'll prove to you why the answer is 675, and then after I prove it to you, you guys will understand it. So let f of n be like the answer, right? Let f of n be the maximum number of points that Veronica can get. So we're looking for f of 100 and f of 1000 here. Now we'll prove by induction that f of n is at least n for n less than or equal to 675. So now let's do the base case induction hypothesis, like the usual stuff, right? The base case, we've already proved that f of 1 is 1, right? So f of 1 is definitely greater than or equal to 1 from part A. And the induction hypothesis, assume that f of 1 is greater than or equal to 1, f of 2 is greater than or equal to 2, and so on until f of k is greater than or equal to k. So we'll use strong induction. And for the induction step, we just need to prove that f of k plus 1 is greater than or equal to k plus 1, right? Now, let's look at how Veronica can actually score points by removing people. So let's call like a dead end someone who has no one pointing to him. So if you have like this graph, then this person is a dead end because no one is pointing to him. And Veronica can choose, well, if there are dead ends, then Veronica can choose any one of the dead ends and then remove the person that dead end is pointing to, right? So if before this was one group, right? Now, by removing the only person that the dead end is pointing to, Veronica has basically disconnected or isolated this dead end from the rest of the group. So now this dead end is its own group, and now like the rest is at least one group. Here it's two groups, but still it's at least one group. So by removing the person, by using only one move or one like removal, Veronica has just scored herself one more point. So if there is at least dead end, then Veronica can remove one person to get 1 point. And by removing one person, she'll have k like removals left. So that's f of k, and she'll get one more point. So f of k plus 1 is at least this, which is at least 1 plus k due to the induction hypothesis, right? So the induction step is complete if there's a dead end. Now, if there isn't a dead end, then let's assume like these are the people who are like left, right? So you can pick any one of them, and then you can just follow like the person that he's pointing to. So this person points to this, now you follow this person who he's pointing to. So say he points to here, right? And say he like points to like this person. So now you have created a loop, right? Notice this person cannot point to like this person because each person is pointed to by exactly one other person, and each person points at exactly one other person. That means each person must be pointed at by exactly one other person, and it must also point to exactly one other person. So this is impossible because this person is pointed at by two people. So, like, assume like he goes here, right? So now this is a loop. And now you can pick any other person. So pick this person. If this person like points to here and say he points here, that's like another loop, right? And then if this person points to here and this person points to here, that's like another loop, right? So it's pretty straightforward why you can split the rest of the like points into groups where each person points to the other people in like a loop pattern. So you can basically just like divide the rest of the people into loops. And now if you have a loop of 2, that's automatically like 1 point by default that Veronica can get. So by removing 0 people, she can get 1 point. And for a loop of 3, that's also 1 point, right? She can remove 0 people to get 1 point. And for a loop of 4, she can remove 2 people who are opposite of each other to get 2 points. And for a loop of 5, she can like same thing, right? And loop of 6, she can remove like every other person to get 3 points by removing 3 people, and so on, right? For a loop of n, you can remove floor of n over 2 to get floor of n over 2 points. All right. Now notice this: the 2025 students, they want Veronica to score the least points possible, and to do so, they can't like just make a bunch of groups of 4, right? Because if they make groups of 4, then Veronica can remove 2 people to get 2 points. So if they make like a bunch of groups of 4s, or like or groups of 5s, or groups of 6s, and so on, then every 4 people, Veronica can get 2 points, and so on until n, right? So the students, they want Veronica to make groups or loops of 3. And notice, you can only make 600, there's 25 students, right? And they must make loops. So if they make like loops of 4, that's disadvantageous for them. So they're automatically going to make like a bunch of loops of 3s, right? And so on, times 675. And by default, Veronica will already score like 675 points. And if they make like groups of 4, say they make like 2 groups of 4, then Veronica can like remove 2 people, and Veronica can remove another 2 people to get 4 points, in addition to like the groups are like no more than 3, right? So now Veronica can get like, so if there are like A groups of 4 or above and B groups of 3 or below, like realistically, the students, they're never going to make groups of 2 because Veronica is going to get 1 point. And if they make groups of 3, Veronica is also going to get 1 point, right? So that means 4A plus 3B must be 2025 because there are 2025 students by default, right? And by default, the 3B becomes B points without using any removals. And using K plus 1 removals, you'll get the minimum of K plus 1 or 2 times A, which is basically just removing like the maximum like number of people that you can. And the number of points that she gets is that. And notice this is greater than or equal to the case where like there's the most like number of B's, right? So this does not depend on K. So so obviously the students, they want Veronica to get the least number of points possible. So they're going to make this 0. Right? They're going to make this 0. That means 4A plus or 4.5, whatever, like based on like the number of groups that, or sorry, the size of the groups that the students make, it must always add up to 2025, right? And that means that f of K plus 1 is at least K plus 1, because you're always going to like pick this one, right? Because if B is like super low, that means A must be super high, and that means A must not be the minimum. And this works given that K plus 1 is no more than 675. So what we have done is we have completed the induction and we have proven that f of n is greater than or equal to n for 675, right? So that means for part B, f of 100 is greater than or equal to 100. And if the students, like, again, just make like a giant loop, and Veronica removes 100 students, Veronica cannot score more than 100 points. Because the people that like are in between and the people that are like not removed, they're just gonna like form loops again. Oh, sorry, they're just gonna be in like the same groups again, right? So Veronica can't get more than 100 points here. So f of 100 is less than or equal to 100. That means f of 100 is equal to 100. So we've just completed part B. We just completed the proof. And for part C, f of 1000 is greater than or equal to f of 675. Obviously, because if you remove more people, then you can get more points, right? And this is by induction greater than or equal to 675. And the students, they can like just make 675 like triangles, right? Using the 2025 like students, they can make 675 triangles. And no matter how many people Veronica chooses to remove from these people, it's always no more than 1 point, right? So Veronica can't not score more than 670 points. That 675 points. That means f of 1000 is also no more than 675. That means that f of 1000 is equal to 675. So part C is also done. And now notice that f of anything, this is just like an extension or like bonus, by the way. F of anything, so like f of n for any n, is no more than 675, because you can just make the triangles again, right? So in fact, if part C asks you for like n equals 1200, the answer would still be 675, and you can just use the exact same proof. So if there was like a part D asking you n equals 1200, then you immediately solve part D as well, right? So this proof is like pretty robust, and it can provide you like a general like answer. And to bound F like above, you can just construct the 675 triangles again. So yeah, this is all parts of the final question on the COMC this year solved. Yeah, thank you for watching if you're still here. We recommend you check out Perry's solution for problem C3.